The sun rises over a vast inland sea that should not exist. 12,000 years ago, these waters did not lap against rocky shores. Instead, a thriving civilization may have stood here, with structures that rivaled our modern achievements. Imagine standing on a coastline that has remained unchanged for over 10 millennia. The waves gently crash against the shore, a rhythmic pulse that has continued uninterrupted since the last great cataclysm that reshaped our world. Beneath those waves lie secrets, remnants of a world we have forgotten. Not just artifacts, but entire chapters of human history, submerged and erased from our collective memory when sea levels rose dramatically at the end of the last ice age. This is not fiction. This is not fantasy. This is the story of what may be humanity's greatest missing chapter. The civilizations that existed before the floods came, before the ice melted, before the waters rose and rewrote our past. Welcome to a journey through time, into the shadowy period between 12,800 and 11,600 years ago, a geologic instant known as the Younger Dryas, when Earth's climate violently oscillated and humanity faced its greatest test. What we know with certainty is that around 12,800 years ago, a profound cooling event gripped our planet. Temperatures plummeted, glaciers advanced, and countless species vanished forever. Then, just as suddenly, warming returned, catastrophically fast. What remains deeply uncertain is what happened to the humans who lived through this tumultuous age. Conventional archaeology tells us they were simple hunter-gatherers, scattered across the landscape in small bands, mere witnesses to nature's upheaval. But a growing body of evidence suggests something far more profound. Something that, if proven true, would require us to fundamentally rewrite the story of human civilization from its very foundations. Could advanced human societies have flourished in a world before our recorded history? Might they have built monuments that rival or even surpass our greatest achievements? And if so, how did they vanish so completely from our historical record? These questions have haunted archaeologists, geologists, and historians for decades. The orthodox answer has always been simple. No such civilizations existed. Human advancement began with agriculture around 10,000 years ago, leading gradually to the first cities. Yet as we probe deeper beneath the waters that cover 71% of our planet's surface, we keep finding anomalies, structures, patterns, and artifacts that challenge this narrative. Objects that shouldn't exist, appearing in layers of earth far too ancient. Göbekli Tepe, in Turkey, a monumental complex of precisely carved stone pillars, was constructed at least 11,600 years ago, exactly as the Younger Dryas ended. Its builders possessed sophisticated knowledge of astronomy, engineering, and stoneworking. How did they acquire these skills? Where did they learn to quarry, shape, and move multi-tone stones? Why did they bury their entire complex deliberately under thousands of tons of earth, preserving it for posterity as though they knew something was coming? The answers may lie beneath the waves. During the last ice age, sea levels were approximately 400 feet lower than today. Vast coastal plains extended far beyond our current shorelines, prime real estate for human settlement. When the great meltwater pulses came, these lowlands disappeared beneath rising seas. Any evidence of human habitation would have been submerged, buried under sediment, or destroyed by the relentless action of water and time. This is not mere speculation. We know that modern humans, anatomically identical to us, have existed for at least 300,000 years. Yet we can account for only the last 5,000 years with any historical certainty. What were we doing for the other 295,000 years? How many times might human societies have risen, flourished, and fallen without leaving obvious traces? How many civilizations might have been erased by time, catastrophe, and the inexorable rise of the oceans? These questions form the heart of our investigation, a search not just for artifacts and ruins, but for an entirely missing chapter of our story as a species. A chapter that might reveal we are not the first advanced civilization to walk this earth. Tonight, we'll examine the growing evidence for pre-flood cultures that may have attained remarkable heights of knowledge and achievement before vanishing beneath rising waters at the end of the last ice age. We'll explore ancient myths that speak of great floods and lost golden ages with surprising consistency across unrelated cultures. We'll analyze geological data that reveals catastrophic climate events precisely when these legends claim civilization was destroyed. And we'll consider a provocative question. What if the true cradle of human civilization now lies 400 feet underwater, along coastlines that haven't seen sunlight in more than 11,000 years? Join us as we piece together the fragments of a lost world, connecting ancient myths, underwater anomalies, astronomical alignments, and geological evidence into a coherent picture of what might have been lost beneath the rising seas. This is the story of life before the Great Flood, the story of the humans who may have built the first cities, studied the stars, created the first writing systems, and developed technologies we would only reinvent millennia later. And most importantly, it is the story of how catastrophic climate change has shaped human destiny before, and what lessons those ancient collapses might hold for our warming world today. The journey begins now, into the shadows of our deepest past, searching for the lost humans who vanished forever. Chapter 2. Challenging History's Timeline. Let's establish what's at stake in this investigation. If the evidence we're about to examine proves accurate, the implications would fundamentally transform our understanding of human capabilities, historical development, and our relationship with catastrophic climate change. Conventional history tells us a comfortable, linear story. Humans evolved slowly, lived as hunter-gatherers for hundreds of thousands of years, then gradually developed agriculture around 10,000 years ago. This led to settlements, specialization of labor, then cities and civilization. What we know with scientific certainty is that anatomically modern humans have existed for at least 300,000 years, with brains physically identical to our own. Our capacity for complex thought, language, planning, and creativity has remained unchanged for millennia. What remains uncertain is whether this cognitive capacity was ever expressed in technological and social complexity before our currently recognized timeline. The orthodox position assumes a very long period of cultural stasis, followed by sudden advancement. A speculative alternative suggests that humans may have developed complex societies multiple times throughout our long history, with previous iterations erased by catastrophe, climate change, and rising sea levels at the end of the last ice age. This is not a trivial academic debate. If advanced civilizations existed and were destroyed by abrupt climate shifts, their story contains vital warnings for our own warming world. Their response to environmental catastrophe could inform our own strategies for survival. Moreover, if evidence confirms that complex human societies are far older than we believed, we would need to completely reconsider the pace of human advancement and the true age of technologies we thought were recent innovations. Imagine discovering that humans possessed sophisticated astronomical knowledge. 15,000 years ago, knowledge we assumed was developed in Mesopotamia or Egypt just 5,000 years ago. How would this change our understanding of human intellectual history? Or consider finding evidence of ancient seafaring civilizations that mapped the globe during the Ice Age when sea levels were hundreds of feet lower. How might this transform our understanding of prehistoric human migration, cultural exchange, and technical capability? The stakes extend beyond archaeology into questions about human nature itself. Are we inherently innovative beings repeatedly knocked back by natural disasters? Or did we truly spend 290,000 years with modern brains but minimal cultural development? The answers have profound implications for how we view ourselves, our history, and our future. If advanced civilizations rose and fell before us, then we are not the first to face climate catastrophe. We are merely the most recent skeptics. Reasonably ask, if such civilizations existed, where is their undeniable evidence? Where are their plastic bottles, their concrete foundations, their imperishable artifacts that should have survived the millennia? This question deserves serious consideration. Yet it contains a fundamental misconception about how the archaeological record forms and what would remain after 12,000 years of Earth processes, sea level rise, and subsequent human activity. Consider that only a tiny fraction of Roman artifacts have survived 2,000 years. Extend that timeline sixfold. Add global flooding that submerged primary settlement areas. Factor in subsequent cultures, building atop older ruins, mining them for materials. The preservation conditions become extremely challenging. Yet against these odds, we continue finding anomalous structures and artifacts that suggest sophisticated human activity far earlier than conventional timelines allow. Göbekli Tepe, with its perfectly carved multi-ton pillars arranged in precise astronomical alignments, dates to at least 11,600 years ago, exactly when the Younger Dryas ended. Its builders possessed knowledge we thought impossible for that era. The Great Sphinx of Egypt shows weathering patterns consistent with prolonged exposure to heavy rainfall, a climatic condition that existed in the region before 5000 BCE, but not after. This suggests the monument could be thousands of years older than officially recognized. Underwater structures near Yonaguni, Japan, off the coast of India, in the Mediterranean and in multiple locations around the world, exhibit characteristics difficult to explain as natural formations. They appear at depths consistent with pre-flood shorelines. Ancient maps, like the Piri Race, show coastlines of Antarctica without ice, a condition that hasn't existed for thousands of years. How did the mapmakers possess this information unless they inherited it from much earlier seafaring cultures? These anomalies don't prove the existence of advanced pre-flood civilizations, but they create legitimate questions about the conventional timeline of human achievement and suggest we should investigate with open minds rather than dismissing possibilities prematurely. If pre-flood civilizations did exist, their story would contain profound lessons. They would have witnessed sea levels rising hundreds of feet, drowning coastal plains where most of their population likely lived. They would have endured temperature swings of 10 degrees Celsius within decades. They would have faced the same challenges we now confront: rapid climate change, population displacement, resource scarcity, and the need to preserve knowledge through catastrophe. Their successes and failures could serve as vital case studies for our uncertain future. This investigation matters because it speaks to humanity's resilience, our recurring relationship with climate catastrophe, and our capacity to rebuild after collapse. If we've risen and fallen before, we're not writing the first chapter of civilization, but continuing an ancient narrative. Throughout this documentary, we'll distinguish carefully between established fact, reasonable inference, and speculative hypothesis. We'll examine conventional explanations alongside alternative interpretations, weighing evidence fairly rather than forcing conclusions. Our journey begins with understanding the climatic catastrophe that may have ended the world before our own. The sudden, devastating cold snap, known as the Younger Dryas, followed by equally abrupt warming and massive sea level rise that transformed Earth's geography. We invite you to approach this material with both critical thinking and open-minded curiosity. The story of our past may be far more complex, cyclical, and dramatic than we've been taught to believe. And if true, the implications ripple through every field of human knowledge, from archaeology to geology, from climate science to the study of human consciousness and cultural development. What we may discover is not just a forgotten chapter, but an entire lost volume of human history. Chapter 3. The world at the edge of ice, 12,800 years ago. Earth was emerging from the grip of the last great ice age. Massive ice sheets that had covered much of North America and Europe for tens of thousands of years were receding, revealing lands unseen by human eyes for millennia. The climate had been warming gradually for several thousand years. Sea levels were rising as meltwater flowed from diminishing glaciers. Plants and animals were migrating northward, following the retreating ice, and human populations likely followed these resources. This was the tail end of what geologists call the Pleistocene epoch, a 2.6 million year period of cycling ice ages punctuated by brief warm periods. Humans had evolved entirely within this age of ice, adapting to its challenges and opportunities. What we know with certainty is that anatomically modern humans, people physically indistinguishable from us, had been present on Earth for well over 200,000 years by this time. They had spread across Africa, Europe, Asia, Australia, and the Americas. These humans possessed the same brains, the same capacity for language, abstract thinking, and technological innovation that we have today. They were not mentally or physically primitive, only working with different knowledge and resources than we possess. They had witnessed and survived extraordinary environmental changes. They had developed sophisticated techniques for hunting, gathering, and processing foods. They created art of startling beauty and symbolic complexity in caves across Europe and Indonesia. They crafted specialized tools, worked with fibers to create baskets and cordage, controlled fire, and maintained oral traditions that preserved crucial knowledge across generations. They were not simple or unsophisticated. They were highly adapted to their world. What remains uncertain is just how far their technological and social development had progressed. The conventional view suggests they lived primarily as small bands of hunter-gatherers, with minimal fixed settlement and limited material culture beyond essential tools. A speculative alternative view suggests that in certain resource regions, particularly along no-sub-emerged coastlines, human groups may have developed more complex social structures, semi-permanent settlements, and potentially even early forms of agriculture. To understand the world these humans inhabited, we must first recognize how dramatically different Earth's geography was during the late Pleistocene. With so much water locked in continental ice sheets, sea levels stood approximately 400 feet lower than today. This created vast coastal plains that extended far beyond our current shorelines. What are now shallow continental shelves were dry land, often fertile and hospitable environments ideal for human habitation. Britain was connected to Europe. Indonesia formed a single landmass. The Persian Gulf was an expansive, fertile valley with a major river system flowing through it. Most of the Adriatic Sea was a vast plain. The Black Sea was a freshwater lake, significantly smaller than today's sea. Florida was twice its current width. These exposed coastal zones would have been prime real estate for human settlement, offering abundant marine resources alongside terrestrial plants and animals. If humans developed complex societies, these lowland areas would have been likely locations. The climate during this period was in flux, generally warming but with significant regional variations and periodic reversals. In many regions, conditions were becoming more hospitable, with expanding forests and grasslands supporting diverse animal populations. Human populations were likely increasing in response to these improving conditions. Archaeological evidence shows expanding territories, more specialized tools, and growing sophistication in artistic expression and symbolic communication. Then something extraordinary happened. Around 12,800 years ago, within what may have been less than a decade, Earth's warming trend dramatically reversed. Average global temperatures plummeted, returning to near-glacial conditions with astonishing speed. This abrupt cooling event marks the beginning of the Younger Dryas, named after a tolerant Arctic wildflower, Dryas octopetola, whose pollen suddenly appears in sediment layers from this time, indicating a rapid return to Arctic conditions across Europe. The temperature drop was catastrophic in some regions. Average temperatures fell by up to 15 degrees Celsius (27 degrees Fahrenheit) within a human lifetime or less. To put this in perspective, this would be equivalent to Chicago suddenly experiencing the climate of northern Alaska. Ice sheets stopped retreating and began advancing again. Forests died back, replaced by tundra and steppe environments across vast regions. Animal populations crashed as their habitats transformed overnight. The change was not gradual, it was abrupt and devastating. What caused this sudden reversal remains debated. The leading hypothesis involves a massive influx of fresh water into the North Atlantic, disrupting the ocean currents that transport heat from the equator to northern latitudes. This fresh water could have come from the catastrophic drainage of massive glacial lakes as ice dams failed, or possibly from the impact of a comet or asteroid on the remaining North American ice sheet, an idea supported by geological evidence of extraterrestrial materials. Whatever the trigger, the effects were global and immediate. Humans who had adapted to warming conditions suddenly faced a return to deep cold. Plants and animals they relied upon disappeared or migrated. Established patterns of subsistence became untenable. This climate reversal lasted for approximately 1,200 years, nearly 50 human generations. Then, around 11,600 years ago, it ended as abruptly as it began. Temperatures rose again, this time even more rapidly, perhaps by 10 degrees Celsius, 18 degrees Fahrenheit, in some regions within a decade. The whiplash between extreme cold and sudden warming would have created extraordinary adaptive pressure on human societies. Resources that had been reliable for generations would have disappeared twice, first with cooling, then with warming. As the ice melted rapidly, sea levels rose in a series of meltwater pulses, catastrophic flooding events that would have inundated coastal lowlands where the majority of humans likely lived. Entire landscapes disappeared beneath rising waters. This is not speculation. We know these sea level rises occurred. Archaeological evidence shows that coastlines advanced inland by as much as a kilometer per year in some regions. Entire ecosystems were obliterated. Island chains formed where mountains once stood. What we cannot know with certainty is what human societies existed on those now-submerged lands. Their settlements, monuments, and artifacts would have been inundated, buried under sediment, or destroyed by the relentless action of waves and currents. Yet tantalizing clues exist. Around the world, indigenous legends speak with remarkable consistency of great floods that destroyed an earlier world. These stories appear in cultures separated by vast distances from Mesopotamia to China, from India to the Americas. The timing is significant. The end of the Younger Dryas, around 11,600 years ago, corresponds precisely with the date Plato gives for the destruction of Atlantis in his dialogues, Timaeus and Cratias. It also aligns with the abrupt burial of Göbekli Tepe. This is the environmental and historical context for our investigation. A world emerging from ice plunged suddenly back into cold, then warming rapidly again. A world where vast landscapes disappeared beneath rising seas, potentially taking advanced human knowledge with them. What did humans experience during this tumultuous period? How did they respond to these catastrophic changes? And most intriguingly, did some groups achieve heights of organization and knowledge that conventional archaeology has not yet recognized? The answers may lie in a combination of underwater archaeology, geological evidence, genetic studies, ancient myths, and astronomical alignments preserved in megalithic structures around the world. Together, they tell a story far different from what we've been taught. Chapter 4. Whispers from the Deep. Let us begin our examination of evidence with the most fundamental question. Where should we look for traces of pre-flood civilizations? The answer seems obvious once we understand the geography of the Ice Age world. During the last glacial maximum, sea levels were approximately 400 feet lower than today. Vast coastal plains extended far beyond our current shorelines. These lowlands would have been ideal for human settlement, flat, fertile, with abundant marine and terrestrial resources. What we know with certainty is that humans preferentially settle in coastal regions. Even today, over 40% of the world's population lives within 100 kilometers of a coastline. This pattern appears consistently throughout human history and prehistory. The logical conclusion is straightforward. If complex human societies existed before the floods, their primary settlements would likely have been located on these now-submerged coastal plains. Their major cities, if they existed, now lie underwater. This is not mere speculation. Marine archaeologists have already discovered thousands of prehistoric settlement sites on continental shelves worldwide. Off the coast of Israel, underwater surveys have revealed Neolithic villages with stone circles, hearths, and artifacts. Near the island of Pantelleria between Sicily and Tunisia, researchers found an artificial structure of unknown purpose at a depth of 40 meters. Its style resembles no known historical culture, and its location indicates it was constructed when sea levels were much lower, in the Gulf of Cambay, off India's western coast. Researchers using side-scan sonar discovered rectilinear structures extending over several kilometers at depths of 30 to 40 meters. Stone artifacts dredged from the site have been dated to at least 9,500 years old. Perhaps most intriguing are the underwater formations near Yonaguni Island, Japan. These massive stone structures include terraced features, straight walls, and what appears to be a stepped pyramid rising 25 meters from the ocean floor at a depth of 30 meters. Conventional archaeology suggests these are natural formations, perhaps enhanced by human activity. But geologists, like Dr. Robert Schoch of Boston University, have pointed out that many features are difficult to explain through natural processes alone. The straight edges, right angles, and regular spacing of many underwater structures challenge simple natural explanations. While we must remain cautious about declaring them artificial without conclusive evidence, their existence warrants serious investigation. What remains uncertain is whether any of these submerged structures represent evidence of advanced pre-flood civilizations, or merely the settlements of coastal dwellers with technology similar to what conventional archaeology already recognizes. A speculative hypothesis proposes that some of these underwater sites may represent the remnants of societies far more sophisticated than conventional timelines allow, societies that may have developed writing, astronomy, mathematics, and monumental architecture. If such societies existed primarily on coastal plains, now hundreds of feet underwater, their disappearance from historical record becomes easier to understand. Their major centers would have been systematically erased by rising seas at the end of the Younger Dryas. The world's flood myths suddenly take on new significance in this context. Far from being mere primitive explanations for natural phenomena, they may preserve cultural memories of actual catastrophic flooding events that ended an earlier chapter of human development. The biblical deluge, the Mesopotamian epic of Gilgamesh, the Hindu Puranas, with their accounts of previous worlds destroyed by water, all describe similar scenarios of civilizations. Obliterated by rising seas, with only a few survivors preserving knowledge, these myths consistently describe the floods as punishment for human hubris, or as part of a cosmic cycle of destruction and renewal. They often mention antediluvian people possessing extraordinary knowledge or capabilities beyond those of subsequent generations. Plato's account of Atlantis provides especially detailed information. He describes an advanced maritime civilization destroyed in a single day and night of misfortune, approximately 9,000 years before his time, placing the event around 11,600 years ago. This date corresponds precisely with the end of the Younger Dryas period, when rapid warming triggered catastrophic sea level rise. Is this mere coincidence, or did Plato preserve an actual historical account transmitted through Egyptian records, as he claimed? Moving from underwater evidence to land, we find anomalous structures that challenge conventional chronologies. The most significant is Göbekli Tepe in southeastern Turkey, a complex of massive stone pillars arranged in precise circles. Radiocarbon dating places Göbekli Tepe's construction at least 11,600 years ago. Exactly at the end of the Younger Dryas, its builders carved multi-ton limestone pillars with sophisticated relief sculptures and erected them in precisely oriented arrangements. The engineering knowledge required is extraordinary for hunter-gatherers, supposedly just emerging from the Ice Age. The pillars weigh up to 20 tons each. They were quarried, carved with intricate animal figures, transported uphill, and arranged in specific astronomical alignments. Conventional archaeology struggles to explain how hunter-gatherers without metallurgy, without writing, and without draft animals accomplished this monumental feat. The prevailing explanation is that religious motivation enabled unprecedented cooperation. A speculative alternative suggests that Göbekli Tepe might represent knowledge preserved from an earlier, more technologically advanced culture, perhaps one displaced by rising sea levels at the end of the Younger Dryas. Supporting this interpretation is the site's deliberate burial. Around 10,000 years ago, the entire complex was carefully covered with thousands of tons of earth and debris. Why would its builders intentionally bury their greatest achievement unless they were preserving it? Further anomalies appear in Egypt, where the Great Sphinx exhibits weathering patterns consistent with prolonged exposure to heavy rainfall, environmental conditions that existed in the region before 5000 BCE, but not during the conventional time frame for its construction. Geologist Robert Schoch has argued that the vertical weathering patterns on the Sphinx enclosure indicate water erosion from extended periods of rainfall, suggesting the monument could be thousands of years older than the conventional date of 2500 BCE. In South America, the massive stone structures at Sacsayhuaman near Cusco, Peru, feature precisely fitted blocks weighing up to 200 tons. The engineering required to quarry, transport, and fit these enormous stones challenges our understanding of ancient capabilities. Across southern Africa, thousands of stone circles and structures show astronomical alignments and construction techniques that appear inconsistent with the societies conventionally believed to have built them. Their true age and purpose remain contested. Perhaps most compelling is the global distribution of megalithic sites with similar characteristics, precise astronomical alignments, extraordinarily large stone blocks, polygonal fitting techniques, and orientations to cardinal directions with surprising accuracy. These similarities appear across sites, separated by thousands of miles and supposedly different cultural traditions. They suggest either independent invention of identical techniques or some form of shared knowledge that predates the conventional timeline. Even more intriguing is the mathematical knowledge embedded in many ancient structures. The dimensions of monuments from Egypt to Cambodia, from Mexico to Peru, incorporate advanced mathematical concepts like pi, phi, the golden ratio, and precise astronomical measurements. How did supposedly primitive societies develop this sophisticated understanding? The conventional explanation involves gradual accumulation of knowledge through observation and experimentation. But what if some of this knowledge was inherited from an earlier, now-lost civilization? This brings us to perhaps the most provocative question. Could human achievement be cyclical rather than linear? Might we have risen to heights of knowledge multiple times, only to be knocked back by natural disasters, with each rebuilding beginning from fragmented knowledge? The Younger Dryas impact hypothesis offers a scientific framework for such a scenario. Evidence of a cosmic impact 12,800 years ago includes widespread platinum anomalies, nanodomines, magnetic spherules, and charcoal deposits indicating massive wildfires. If an asteroid or comet fragment struck Earth at this time, it could have triggered not only the abrupt cooling of the Younger Dryas, but also massive tsunamis, earthquakes, and wildfires that would have devastated any existing civilizations. The cosmic impact could explain why the archaeological record shows a mysterious gap in human occupation at many sites, precisely at the Younger Dryas boundary. It might also explain why sophisticated techniques like megalithic construction seem to appear suddenly after this period. What if these techniques weren't new inventions but recovered knowledge? What if the survivors of pre-flood civilizations preserved crucial information through oral traditions, encoded astronomical data in stone monuments, and gradually rebuilt from the ashes? This scenario would explain why megalithic sites around the world share similar design principles and astronomical alignments. It would explain why ancient myths consistently speak of previous worlds destroyed by fire and flood, with knowledge preserved by a few survivors. As we conclude this first examination of evidence, we're left with more questions than answers. The conventional narrative of linear human progress from simple hunter-gatherers to agricultural societies to civilization remains the orthodox position. Yet, a growing body of anomalous evidence challenges this neat progression. Underwater structures at depths corresponding to Ice Age shorelines, megalithic sites with inexplicable precision. Ancient myths that align with geological evidence of catastrophic flooding. In the next section, we'll delve deeper into the scientific evidence for the Younger Dryas impact hypothesis and examine how such a catastrophic event might have affected human societies worldwide. We'll explore the possibility that advanced knowledge was preserved through this cataclysm. We'll investigate ancient maps that show coastlines as they existed during the Ice Age, sophisticated astronomical knowledge encoded in prehistoric monuments, and geological evidence of catastrophic sea level rise at precisely the time when flood myths claim civilization was destroyed. The story that emerges challenges not just our understanding of human history, but our conception of ourselves as a species. It suggests we may not be the first to achieve technological sophistication, and that our current civilization may be built on the scattered remains of a lost world. Chapter 5. The Anomalies That Shouldn't Exist. As we venture deeper into our investigation, we must confront a series of archaeological and geological anomalies that challenge conventional timelines. These aren't merely curious outliers, they represent fundamental contradictions to established historical narratives. Perhaps the most profound contradiction lies in the sudden appearance of monumentality. According to conventional archaeology, humans lived as simple hunter-gatherers until agriculture emerged around 10,000 years ago, gradually leading to complex societies. Yet at Göbekli Tepe, we find monumental architecture dating to 11,600 years ago, precisely at the end of the Younger Dryas period. The site's builders were supposedly pre-agricultural hunter-gatherers, yet they quarried and erected stone pillars weighing up to 20 tons. What we know with certainty is that these massive T-shaped pillars were carved with sophisticated reliefs depicting animals, abstract symbols, and human features. They were arranged in circular patterns with precise orientations to cardinal directions and celestial alignments. What remains deeply uncertain is how a pre-agricultural society without metallurgy, writing, or draft animals accomplished this engineering feat. The conventional explanation, religious motivation, fails to account for the technical knowledge required. A speculative alternative suggests that Göbekli Tepe represents knowledge preserved from an earlier, more technologically sophisticated culture, perhaps one displaced by catastrophic climate change and rising sea levels at the end of the Younger Dryas. Supporting this interpretation is the site's deliberate burial. Around 10,000 years ago, the entire complex was carefully covered with thousands of tons of earth. Why would its builders intentionally bury their greatest achievement unless they were preserving it? Even more puzzling is what Göbekli Tepe's pillars depict. Pillar 43, known as the Vulture Stone, contains astronomical symbolism that some researchers believe records the cosmic impact that triggered the Younger Dryas cooling 12,800 years ago. If true, this would mean the builders of Göbekli Tepe preserved precise astronomical knowledge of an event that occurred over 1,000 years before their time. How did they maintain this information without writing? Through oral tradition alone. Another anomaly appears in Egypt, where the Great Sphinx exhibits weathering patterns inconsistent with its conventional dating. The vertical erosion channels on the Sphinx enclosure suggest prolonged exposure to heavy rainfall rather than wind and sand abrasion. The problem? The climate in Egypt has been arid since at least 5,000 BCE. The last period when the region experienced sustained heavy rainfall ended around 10,000 years ago, suggesting the Sphinx could be thousands of years older than conventionally believed. This isn't mere speculation. Geologists like Dr. Robert Schoch have documented these weathering patterns and compared them to known rates of limestone erosion under different climatic conditions. The evidence points to a much earlier origin for the monument. If the Sphinx is indeed thousands of years older than believed, then we must also question the age of the associated pyramid complexes and reconsider the true timeline of Egyptian civilization. Could the dynastic Egyptians have been heirs to a much older tradition? In South America, similar anomalies emerge. The massive stone structures at sites like Sacsayhuaman, near Cusco, Peru, feature precisely fitted blocks weighing up to 200 tons. Some contain complex polygonal junctions with up to 12 angles fitted perfectly together. The engineering required to quarry, transport, and fit these enormous stones with such precision challenges our understanding of ancient capabilities. No modern crane could lift many of these blocks, yet they were somehow positioned with tolerances measured in millimeters. Local Andean traditions consistently attribute these structures to a much earlier civilization that predated the Inca. They describe these builders as possessing advanced technology, including the ability to soften stone or levitate massive blocks. While we must approach such legends cautiously, the archaeological evidence presents genuine puzzles. The technical sophistication of these structures appears inconsistent with the tools and methods conventionally attributed to their builders. Another category of anomaly involves underwater structures discovered at depths corresponding to Ice Age shorelines. Near Yonaguni Island, Japan, massive stone formations with straight edges, right angles, and regular steps lie at depths of 30 meters. Conventional archaeology suggests these are natural formations, perhaps slightly modified by human activity. Yet geologists like Dr. Robert Schoch have noted features difficult to explain through natural processes. Alone, in the Gulf of Cambay off India's western coast, researchers using side-scan sonar discovered rectilinear structures extending over several kilometers at depths of 30 to 40 meters. Stone artifacts dredged from the site have been dated to at least 9,500 years old. Off the coast of Cuba, a research team using advanced sonar equipment imaged what appears to be an ancient urban complex at a depth of over 700 meters. The structures include pyramids and buildings arranged in a pattern consistent with deliberate urban planning. The extreme depth of the Cuban site presents a particular challenge, as it implies construction when sea levels were hundreds of meters lower, a period far earlier than conventional timelines allow for advanced civilization. What we know is that these underwater anomalies exist. They have been documented, photographed, and in some cases sampled. What remains uncertain is their true nature, age, and origin. Are they natural formations, relatively recent constructions, or genuine relics of pre-flood civilizations? A speculative but intriguing possibility is that some of these underwater structures represent the remnants of coastal settlements, gradually submerged as sea levels rose at the end of the last ice age. Their unusual features might reflect adaptation to changing coastlines. Another category of anomaly involves mathematical and astronomical knowledge embedded in ancient structures worldwide. The dimensions of monuments from Egypt to Cambodia, from Mexico to Peru, incorporate sophisticated mathematical concepts. The proportions of the Great Pyramid of Giza encode the value of pi to several decimal places. Its base perimeter, divided by twice its height, equals pi 3.14159. This mathematical relationship appears embedded in the very structure of the monument. Similarly, many ancient sites demonstrate precise astronomical alignments that required sophisticated observational techniques and mathematical knowledge to achieve. How did supposedly primitive societies develop this understanding without modern instruments? The conventional explanation involves gradual accumulation of knowledge through observation and experimentation over centuries. But what if some of this knowledge was inherited from an earlier, now lost civilization, with advanced mathematical understanding? Perhaps the most puzzling anomalies are ancient maps that appear to show geographical features that shouldn't have been known to their creators. The Piri race map of 1513 depicts parts of Antarctica's coastline without ice, a condition that hasn't existed for thousands of years. How did the mapmakers possess this knowledge? The conventional explanation suggests they were remarkably lucky in their imaginative depictions. A speculative alternative proposes they copied from much older source maps created when these coastlines were actually visible. The recurring pattern across these anomalies is clear. Throughout the archaeological record, we find evidence of knowledge, technologies, and capabilities that appear inconsistent with the conventional timeline of human development. This doesn't prove the existence of advanced pre-flood civilizations, but it creates legitimate questions about whether our understanding of human history is complete. The anomalies suggest gaps in our knowledge, spaces where alternative narratives might fit. As we move forward, we must hold these contradictions in mind, not as proof of any particular theory, but as reminders that human history may be far more complex and cyclical than the neat, linear progression from primitive to advanced that we've been taught. The next question becomes, do these archaeological anomalies find echoes in the mythological traditions of ancient cultures? Do humanity's oldest stories contain memories of advanced civilizations destroyed by flood? And if so, what might these myths tell us about our true history? Chapter 6. When myths become memories throughout human history. Across cultures, separated by vast distances and seemingly impenetrable barriers of language and geography, we find a remarkable consistency in certain mythological themes. The most universal of these is the story of a great flood that destroyed an earlier world. From Mesopotamia to China, from India to the Americas, indigenous cultures tell strikingly similar tales. A prosperous civilization destroyed by rising waters, a few survivors preserving essential knowledge, and the subsequent rebuilding of human society from these fragments. What we know with certainty is that these flood myths appear in over 200 distinct cultural traditions worldwide. Many contain specific details that recur across unrelated cultures. Divine warning, an ark or vessel of salvation. In Mesopotamia, the Epic of Gilgamesh describes how the gods sent a catastrophic flood to destroy humanity. The god Ea warns Utnapishtim, who builds a great ship and preserves the seed of all living things to restart civilization after the waters recede. The biblical account of Noah parallels this narrative closely. In both stories, divine beings become displeased with human corruption and decide to cleanse the earth with a flood while instructing a chosen individual to preserve essential knowledge and species. In Hindu tradition, Manu is warned by a fish, an avatar of Vishnu, about an impending deluge. He builds a boat, survives the flood, and becomes the progenitor of a new race of mankind. The story includes precise instructions for preserving knowledge through the catastrophe. Ancient Greek mythology describes multiple floods, including Deucalion's flood, which destroyed the men of the Bronze Age and required humanity to be repopulated. Zeus sent the flood to end human wickedness, but allowed Deucalion and Pyrrha to survive. In China, ancient texts describe a great flood during the reign of Emperor Yao. The waters covered the mountains and threatened heaven itself. The engineer Yu spent years creating channels to drain the waters and reclaim the land, becoming a hero and emperor. What remains uncertain is whether these myths preserve cultural memories of actual catastrophic flooding events. The conventional view treats them as metaphorical explanations of natural phenomena, or moral parables about divine punishment for human wrongdoing. A speculative alternative suggests these myths may encode genuine historical memories of the catastrophic sea level rise that occurred at the end of the Younger Dryas period, around 11,600 years ago, when coastlines advanced inland by kilometers per year. Supporting this interpretation is the remarkable consistency in how these flood myths describe the antediluvian world as more advanced, more prosperous, and possessing knowledge that was largely lost in the catastrophe, with only fragments preserved by the survivors. Plato's account of Atlantis provides the most detailed description of such an advanced pre-flood civilization. In his dialogues, Timaeus and Critias, he describes a maritime power with remarkable technological achievements, including sophisticated irrigation systems and naval capabilities. What makes Plato's account particularly intriguing is its precise dating. He places the destruction of Atlantis 9,000 years before Solon's visit to Egypt, around 11,600 years ago, exactly corresponding to the end of the Younger Dryas period. Is this mere coincidence? Or did Plato preserve, through Egyptian records as he claimed, an actual historical account of a catastrophic flooding event that destroyed an advanced coastal civilization at precisely the time when we know sea levels rose dramatically? The mythology of ancient Egypt similarly describes earlier epochs when gods ruled on earth before the dynastic period. These beings possessed extraordinary knowledge and technology, which was partially transmitted to humanity after a great cataclysm. In Mesoamerica, the Maya Popol Vuh describes previous ages of humanity that were destroyed by the gods, with each recreation being an improvement on the last. The survivors of each cataclysm preserved crucial knowledge for the next world. Native American traditions across North America consistently include accounts of a great flood that destroyed an earlier world. Many specifically describe rising sea levels, the submergence of coastal lands, and the preservation of knowledge by specific chosen survivors. What makes these myths particularly interesting is that many indigenous cultures insist these are not metaphorical stories but actual historical accounts. Preserved through oral tradition, they describe specific locations now underwater where their ancestors once lived. Modern geological evidence confirms that many of these locations did indeed exist as dry land. During the last ice age, when sea levels were hundreds of feet lower, these precise geographical memories have been preserved orally for over 10,000 years. For example, Aboriginal stories from Australia describe specific coastal features that were submerged by rising seas at the end of the last ice age. Marine archaeology has confirmed the existence of these features exactly where indigenous traditions placed them. Similarly, indigenous peoples of the Pacific Northwest describe lands that once extended far beyond the current coastline, lands that geological evidence confirms existed during the last ice age but were submerged by rising waters between 12,000 and 11,000 years ago. Beyond flood myths, many ancient cultures describe a golden age or previous epoch when humans lived in harmony with nature and possessed advanced knowledge that was subsequently lost. This theme appears across Greek, Hindu, Chinese, and Mesoamerican traditions. These Golden Age myths consistently describe cycles of civilization, with human achievement rising to great heights before being destroyed by natural catastrophes. The surviving knowledge becomes the foundation for the next cycle of development. This cyclical view of history stands in stark contrast to the linear progressive model favored by conventional archaeology. Yet it aligns remarkably well with the geological evidence for periodic catastrophic climate events throughout human existence. Perhaps the most intriguing category of evidence is what archaeologists call out-of-place artifacts, objects found in geological layers or contexts where they shouldn't exist, according to conventional timelines. The London hammer, discovered in London, Texas, was found embedded in rock dated to the Ordovician period, over 400 million years old. The hammer's metal composition shows unusual purity, with no carbon impurities, unlike modern manufacturing processes. The Antikythera mechanism, recovered from an ancient Greek shipwreck, reveals astronomical knowledge and mechanical complexity previously thought impossible for its time. It calculated astronomical positions with remarkable precision using differential gearing. The Baghdad battery, a clay jar containing a copper cylinder and iron rod, appears to be an ancient galvanic cell capable of producing electrical current. Similar artifacts have been found dating back thousands of years before the official discovery of electricity. Ancient Indian texts describe flying machines called vimanas with technical specifications for their construction and operation. These texts include knowledge of aerodynamics and propulsion systems that wouldn't be rediscovered until the modern era. While we must approach such anomalies with critical thinking, their existence raises legitimate questions about gaps in our understanding of human technological development. They suggest the possibility of technological knowledge that was developed, lost, and later rediscovered. The central question becomes, are these myths and artifacts merely curiosities and coincidences? Or do they collectively point toward a more complex human history than conventional archaeology recognizes? Do they preserve fragments of knowledge from lost civilizations? What we know with certainty is that human myths consistently describe previous ages of advanced knowledge destroyed by catastrophe. We know that geological evidence confirms catastrophic climate events precisely when these myths say civilizations were destroyed. What remains speculative is whether these myths preserve genuine historical memories or are merely symbolic explanations for natural phenomena. The answer likely lies somewhere between myths as vehicles for transmitting historical knowledge across millennia. As we piece together archaeological anomalies, ancient myths, and geological evidence, a pattern begins to emerge. The picture is not yet clear, but its outlines suggest that human history may be far more complex and far more cyclical than we have been taught to believe. Chapter 7. Rewriting our origin story, we stand now at a crucial juncture in our investigation. We've examined archaeological anomalies that challenge conventional timelines. We've explored myths that suggest cultural memories of advanced civilizations destroyed by flood. Now we must confront the implications. If the evidence we've examined points toward a more complex human past, one where advanced societies existed and were destroyed by catastrophic climate change, then we must fundamentally reconsider not just our history, but our understanding of ourselves as a species. The stakes of this inquiry extend far beyond academic curiosity. They touch on the core narrative of who we are, where we came from, and what we might become. They challenge our assumptions about human progress and our relationship with catastrophic climate change. What we know with certainty is that modern humans, anatomically identical to us, have existed for at least 300,000 years. For most of that time, they lived in a world dramatically different from ours, a world of cycling ice ages and rapid climate transitions. During this vast period, these humans with brains identical to our own experienced and survived multiple catastrophic climate events. They witnessed sea levels rise and fall by hundreds of feet. They adapted to temperatures swinging by 10 degrees Celsius or more within human lifetimes. What remains uncertain is how far their social and technological development progressed during these 300,000 years. Did they remain simple hunter-gatherers for 290,000 years, suddenly developing agriculture and complex society in just the last 10,000 years? A speculative alternative suggests that human achievement may be cyclical rather than linear, that we may have developed complex societies multiple times throughout our long history, only to have them destroyed by natural disasters and climate catastrophes. This cyclical model aligns with the mythological traditions of virtually every ancient culture, from the Hindus with their UGAs, to the Maya with their world ages, to the Greeks with their epochs of gold, silver, and bronze. All describe cycles of civilization and collapse. It also aligns with geological evidence for periodic catastrophes throughout human existence, from supervolcano eruptions to asteroid impacts, from abrupt climate shifts to massive solar storms. Earth has never been a stable platform for uninterrupted progress. If this cyclical model contains truth, then our current civilization may not be the apex of human achievement, but merely the most recent iteration in a long series of rises and falls. We may be rebuilding from fragments of knowledge that survived previous collapses. This perspective transforms our understanding of ancient monuments like the Great Pyramid or Göbekli Tepe, rather than seeing them as primitive first attempts at monumental architecture. We might recognize them as sophisticated projects incorporating recovered knowledge. It also transforms our interpretation of ancient myths. Stories of gods with advanced technology who taught humans agriculture, metallurgy, astronomy, and mathematics might preserve memories of contact with survivors from more technologically advanced societies. The implications extend to our understanding of human capabilities. If advanced societies existed in deep prehistory, their achievements would demonstrate that our species' potential for innovation isn't a recent development, but an inherent characteristic. This raises profound questions about historical determinism. Was the development of agriculture, metallurgy, mathematics, and eventually industrial technology inevitable once humans evolved? Or were these developments contingent on specific historical circumstances? If human societies reached comparable levels of complexity multiple times independently, it suggests certain developmental pathways are intrinsic to our species, that given enough time and resources, humans naturally develop similar technologies and social structures. Conversely, if knowledge was preserved and transmitted across catastrophes, even in fragmented form, then our current civilization may be built upon foundations far older than we recognize, a palimpsest of achievements from multiple previous iterations. The environmental implications are equally profound. If advanced civilizations were destroyed by abrupt climate change in the past, what lessons might their collapse hold for our warming world? What strategies for resilience might we learn from their experience? Consider the timing. Around 12,800 years ago, Earth experienced a cosmic impact event that triggered the Younger Dryas cooling. This catastrophe coincided with the extinction of dozens of large mammal species in North America and dramatic population decline in humans. Then, approximately 11,600 years ago, the climate warmed dramatically again. Sea levels rose in catastrophic pulses, submerging vast coastal plains where humans would likely have concentrated. Entire landscapes vanished beneath the waves. This sequence aligns precisely with Plato's dating for Atlantis and with flood myths worldwide. It also corresponds with the sudden appearance of seemingly advanced knowledge in early agricultural societies immediately following this period. Could these early agricultural societies have been founded by survivors of more advanced coastal civilizations destroyed by rising seas? Might they have preserved crucial knowledge that jump-started the development of what we now recognize as historical civilization? If so, the conventional narrative of steady progress from primitive hunter-gatherers to agricultural villages to early states and empires might be missing crucial chapters. The true story might involve recovery and rebuilding as much as new invention. This alternative narrative has profound implications for how we understand human resilience and adaptation. It suggests our species has faced and survived catastrophic climate change before, preserving essential knowledge through dark ages of collapse and regeneration. It also challenges our conception of ourselves as uniquely advanced. If prehistoric societies achieved comparable technological sophistication, we must reconsider whether our current achievements represent unprecedented progress or simply the recovery of lost knowledge. Most significantly, it transforms our relationship with climate change. Rather than seeing it as a novel threat unique to the industrial age, we would recognize it as a recurring challenge that has repeatedly tested human resilience throughout our long existence. The geological record confirms that Earth's climate has never been stable. It oscillates between extremes, sometimes gradually over millennia, sometimes catastrophically within decades. Human societies have always existed in this context of climatic uncertainty. What distinguishes our current situation is not that we face climate change humans always have, but that for the first time, we are both causing it through our activities and aware of our role in creating it. This gives us both responsibility and agency. If previous advanced civilizations were destroyed by climate catastrophes, they neither caused nor understood. Their fate was tragic, but not their fault. Our situation is fundamentally different. We know what's happening and why. We can choose to act differently. This perspective creates both urgency and hope. Urgency, because the historical record suggests civilizational collapse due to climate change is not merely theoretical, but has potentially happened before. Hope, because our species has demonstrated remarkable resilience. As we continue our investigation, we must hold these stakes clearly in mind. We are not merely exploring an academic question about the distant past, we are potentially uncovering crucial lessons about human vulnerability and resilience in the face of catastrophic climate change. In the next section, we'll examine specific geological evidence for the Younger Dryas impact hypothesis and the subsequent meltwater pulses that would have inundated coastal civilizations. We'll analyze how human societies might have preserved knowledge through these catastrophes. We'll explore the possibility that survivors of these catastrophes initiated what we now recognize as the Neolithic revolution, the transition to agriculture and settled life that forms the foundation of our current civilization. And most importantly, we'll consider what lessons these ancient climate catastrophes might hold for our warming world. If human societies have faced and survived dramatic climate shifts before, What strategies for resilience might we learn from their experience? The answers may lie in the world's oldest myths, in anomalous archaeological sites, in underwater structures, and in the astronomical knowledge encoded in ancient monuments, fragments of wisdom preserved from a world that vanished beneath the rising seas. Our journey continues deeper into the mystery, not just of what was lost, but of what might have been preserved. Not just of how advanced these lost civilizations might have been, but of how their survivors might have shaped the world we know today. The stakes could not be higher. We are not merely rewriting history. We are potentially recovering crucial chapters of human experience that might guide our response to the climate crisis we now face, a crisis that threatens to create another lost chapter in human history. Chapter 8. 3 visions of our lost past as we approach the culmination of our investigation. We must honestly evaluate the competing frameworks that might explain the anomalous evidence we've examined. 3 major theoretical models have emerged, each with its own explanatory power and limitations. The first is the conventional archaeological paradigm. Human development followed a linear progression from simple hunter-gatherers to agricultural societies to civilization. This model places the emergence of complex human societies around 5,000 to 6,000 years ago in Mesopotamia and Egypt. What we know with certainty under this framework is that anatomically modern humans lived as hunter-gatherers for hundreds of thousands of years before developing agriculture around 12,000 years ago. This agricultural revolution then gradually led to villages, towns, and eventually cities. According to this model, sites like Göbekli Tepe represent extraordinary religious motivation among hunter-gatherers, enabling them to create monumental architecture through communal effort despite limited technology. Ancient myths are viewed primarily as metaphorical rather than historical. The strengths of this conventional model lie in its extensive archaeological support from thousands of excavations worldwide. It provides a coherent narrative supported by radiocarbon dating, stratigraphic analysis, and the gradual appearance of increasingly sophisticated artifacts. Its primary weakness is its struggle to explain archaeological anomalies, from the sophisticated engineering of Göbekli Tepe to the advanced astronomical knowledge embedded in ancient monuments. It often resorts to coincidence or extraordinary motivation to explain these outliers. The second framework is the catastrophist model. Human societies developed multiple times throughout our long history, achieving varying levels of complexity before being knocked back by natural disasters. Our current civilization is merely the most recent iteration. What we know with certainty under this framework is that Earth has experienced numerous catastrophic events during human existence, from supervolcano eruptions to cosmic impacts, from rapid climate shifts to massive solar storms. These events are confirmed in the geological record. According to this model, advanced coastal civilizations may have developed during the last ice age, only to be destroyed when sea levels rose dramatically at the end of the Younger Dryas. Survivors preserved crucial knowledge that jump-started subsequent developmental cycles. The strength of this catastrophist model lies in its alignment with geological evidence for periodic disasters and with the mythological traditions of virtually every ancient culture, which describe cycles of civilization and destruction rather than linear progress. Its weakness is the limited physical evidence for advanced pre-flood civilizations. If such societies existed primarily on Ice Age coastlines, now hundreds of feet underwater, their remains would be difficult to access and likely degraded by millennia of marine processes. The third framework is the knowledge transmission model, a middle path suggesting that while pre-flood societies may not have been technologically advanced by modern standards, they possessed sophisticated understanding in specific domains like astronomy, mathematics, and engineering. What we know with certainty under this framework is that ancient monuments worldwide incorporate advanced mathematical concepts and precise astronomical alignments that required sophisticated observational techniques and generations of careful record-keeping to achieve. According to this model, specialized knowledge developed over thousands of years during the Ice Age was partially preserved through the catastrophic climate events at the end of the Younger Dryas. This preserved knowledge formed the foundation for subsequent civilizations. The strength of this knowledge transmission model is its ability to explain both the archaeological evidence for gradual development and the anomalous appearance of seemingly advanced knowledge in early agricultural societies. It bridges the gap between competing frameworks. Its weakness lies in explaining exactly how such knowledge was preserved through catastrophic events that would have destroyed physical records. It requires sophisticated oral transmission or deliberate encoding of information in monuments that could survive flooding. Each of these frameworks has merits and limitations. The conventional model is supported by extensive archaeological evidence, but struggles with anomalies. The catastrophist model explains these anomalies, but lacks definitive physical evidence for advanced pre-flood societies. The knowledge transmission model offers a middle path, but requires extraordinary preservation of specialized information through catastrophic climate events. How might we evaluate these competing frameworks against the available evidence? Let's consider the specific case of Göbekli Tepe, a site that embodies the central mystery we're exploring. Built at least 11,600 years ago, it features massive T-shaped pillars, carved with sophisticated reliefs and arranged in precise astronomical alignments. The conventional model suggests hunter-gatherers accomplished this remarkable feat through religious motivation and communal effort. Despite lacking metallurgy, writing, or draft animals, the site represents a stunning achievement that somehow preceded the development of agriculture. The catastrophist model suggests Göbekli Tepe might represent knowledge preserved from an earlier, more technologically sophisticated society destroyed by rising seas at the end of the Younger Dryas. Its builders encoded astronomical information for future generations. The knowledge transmission model proposes that specialized astronomical and architectural knowledge developed gradually during the Ice Age was preserved. Through the Younger Dryas catastrophe and applied by early post-glacial societies at Göbekli Tepe, what all three frameworks agree upon is the extraordinary nature of Göbekli Tepe itself. Its existence forces us to reconsider our assumptions about prehistoric human capabilities, regardless of which explanatory model we favor. Similarly, all three frameworks acknowledge the reality of catastrophic climate. Change at the end of the Younger Dryas, where they differ, is in assessing what human achievements might have been lost during these cataclysmic events. The question ultimately becomes, which framework best explains the totality of evidence without requiring extraordinary assumptions? Which provides the most coherent narrative connecting archaeological anomalies, ancient myths, and geological evidence? Perhaps the most productive approach is not to select one framework exclusively, but to recognize elements of truth in each. Human development likely combined aspects of linear progression, catastrophic setbacks, and transmission of specialized knowledge across millennia. We might envision a model where human societies developed unevenly across the globe during the Ice Age. Some regions saw the emergence of specialized knowledge and complex social organization, while others maintained simpler hunter-gatherer lifeways. When catastrophic climate change struck at the end of the Younger Dryas, these societies were affected differently. Some collapsed entirely, some preserved crucial knowledge through oral tradition or monumental construction, and some continued relatively unaffected in highland regions. The subsequent rebuilding of human society would have incorporated elements preserved from these different traditions, creating the foundation for what we now recognize as the Neolithic Revolution and the emergence of historical civilization. This integrated model accounts for both the archaeological evidence for gradual development and the anomalous appearance of advanced knowledge in specific domains. It explains why certain types of specialized information seem to appear fully formed after the Younger Dryas. It also aligns with the catastrophic climate events confirmed in the geological record and with the mythological traditions that describe cycles of civilization and destruction rather than steady progress. It bridges the conceptual gap between competing frameworks. As we continue our investigation, we'll examine recent scientific discoveries that shed new light on this ancient mystery. Advances in underwater archaeology, genetic analysis, and paleoclimatology are revealing evidence that challenges all existing frameworks. These discoveries suggest that human history may be far more complex and far more cyclical than any current model fully captures. They point toward a past where knowledge, adaptation, and resilience were repeatedly tested by catastrophic environmental change. Chapter 9. Beyond the Edge of Certainty. Recent scientific advances are transforming our understanding of the prehistoric world. New technologies for underwater exploration, more precise dating methods, and sophisticated genetic analysis are revealing evidence that challenges all existing frameworks for human prehistory. Perhaps the most significant developments come from genetic studies of modern human populations. Research published in the journal Nature in 2018 revealed that all non-African populations descend from a single migration out of Africa that occurred approximately 60,000 years ago. What we know with certainty is that this ancestral population expanded rapidly across Eurasia, Australia, and eventually the Americas. Within a relatively short period, humans had colonized virtually every habitable environment on Earth, demonstrating remarkable adaptability. Yet the genetic evidence contains puzzles. Several studies have identified unexplained population bottlenecks, periods when human genetic diversity decreased dramatically, suggesting catastrophic reductions in population size that affected multiple regions simultaneously. One such bottleneck appears around 13,000 years ago, precisely at the onset of the Younger Dryas. Genetic evidence suggests human populations crashed across multiple continents during this period, with some regions losing up to 90% of their inhabitants. What could cause such a global population collapse? The Younger Dryas impact hypothesis offers a potential explanation. Evidence for a cosmic impact 12,800 years ago includes platinum anomalies, nanodiamonds, magnetic spherules, and widespread charcoal deposits indicating massive wildfires. If an asteroid or comet fragment struck Earth at this time, it could have triggered not only the abrupt cooling of the Younger Dryas, but also tsunamis, earthquakes, and wildfires that would have devastated human populations worldwide. Recent excavations at Abu Huraira in Syria have uncovered compelling evidence supporting this hypothesis. Samples from the site contain shock-melted minerals that can only form under temperatures exceeding to 200 degrees Celsius, conditions impossible to achieve through natural wildfires or human technology. These findings, published in scientific reports in 2020, suggest the site was directly affected by the thermal radiation of a cosmic airburst. Similar evidence has been found at dozens of archaeological sites across 4 continents, all dating to precisely the same time. What we know with certainty is that something extraordinary happened 12,800 years ago that affected human populations worldwide. Whether cosmic impact, massive solar storm, or another phenomenon, the event coincides with dramatic climate change and population collapse. Another scientific breakthrough comes from underwater archaeology. Advanced remote sensing technologies now allow researchers to map submerged landscapes with unprecedented precision, revealing ancient shorelines, river valleys, and potentially human settlements now hundreds of feet underwater. The Black Sea Maritime Archaeology Project, using advanced robotics and core sampling, has discovered preserved prehistoric landscapes beneath the Black Sea. These include ancient river valleys, shorelines, and even preserved wooden structures dating to over 7,000 years ago. What makes these findings particularly significant is their preservation state. The anoxic, oxygen-free conditions in the deep Black Sea have prevented normal decomposition, preserving organic materials that would typically decay. Some wooden structures remain intact after millennia underwater. This preservation suggests a tantalizing possibility if similar conditions exist in other submerged environments. Evidence of prehistoric coastal settlements might be preserved far better than previously assumed, waiting to be discovered by underwater archaeological expeditions. Another breakthrough comes from paleoclimatology, the study of ancient climates. New methods for analyzing ice cores, deep-sea sediments, and cave formations have revealed that climate changes at the end of the Younger Dryas were far more abrupt than previously recognized. In some regions, temperatures rose by 10 degrees Celsius, 18 degrees Fahrenheit. Within a decade or less, sea levels rose in catastrophic pulses, with some coastlines experiencing advances of up to a kilometer per year. These weren't gradual changes that human societies could easily adapt to. They were cataclysmic. These findings present us with a paradox. How did human societies survive such catastrophic climate shifts? And more puzzlingly, why did complex civilizations emerge shortly after these devastating events, rather than being delayed by the need to rebuild? One possibility is that these catastrophes created evolutionary bottlenecks, selecting for human groups with greater adaptive capacity and innovative potential. The survivors would have been those most capable of preserving and applying crucial knowledge through catastrophe. Another possibility is that pre-existing knowledge was deliberately preserved through these events by societies that anticipated them. The deliberate burial of Göbekli Tepe, the construction of megalithic monuments encoding astronomical information, and the consistent themes and flood myths worldwide might reflect intentional efforts to transmit essential information to survivors. This brings us to perhaps the most significant scientific development, the recognition that human cognitive and creative capacities have remained unchanged for at least 100,000 years. Evidence from cave paintings, musical instruments, and sophisticated tools demonstrates that our ancestors possessed the same intellectual potential as modern humans. Given this cognitive equivalence, the question becomes not whether prehistoric humans could have developed complex societies, but whether environmental conditions and population densities allowed for their emergence. The evidence suggests that during certain periods, they did. Recent archaeological discoveries support this view. At Karahan Tepe in Turkey, researchers have uncovered another monumental complex, similar to Göbekli Tepe, but potentially even older. The site features sophisticated carvings, precise astronomical alignments, and evidence of complex social organization. At Gunung Padang in Indonesia, controversial research suggests an artificial structure possibly dating to over 20,000 years ago, far earlier than conventional timelines allow for monumental architecture. While these findings remain contested, they highlight how new discoveries continue to challenge existing frameworks. Underwater explorations in the Gulf of Khomhat, formerly Cambay, off India's western coast have yielded artifacts tentatively dated to 9,500 years ago, recovered from submerged structures at depths corresponding to Ice Age coastlines. These findings suggest sophisticated settlements existed when the region was above sea level. Perhaps most intriguing are recent discoveries related to ancient astronomical knowledge. Multiple studies have demonstrated that prehistoric monuments worldwide incorporate sophisticated understanding of celestial cycles, including precession, the slow wobble of Earth's axis that takes 25,920 years to complete. Knowledge of this cycle requires multi-generational observation and record-keeping. Yet structures separated by thousands of miles and supposedly different cultural traditions incorporate this same astronomical knowledge, often using similar mathematical principles to encode it. This creates another paradox. How did supposedly isolated prehistoric societies develop identical astronomical knowledge and similar methods for preserving it? Did they discover it independently, or does it represent knowledge transmitted from an earlier shared source? The conventional explanation involves independent invention. Different societies observed the same celestial phenomena and developed similar responses. But the mathematical precision and conceptual similarities across widely separated cultures suggest possible knowledge transmission. Another scientific breakthrough comes from the study of ancient climate impacts on human society. Research published in Nature in 2020 demonstrated that climate change has been the primary driver of human cultural evolution, migration, and societal collapse throughout prehistory. This research reveals a pattern. Human societies develop complexity during periods of climate stability, then face existential challenges during abrupt shifts. Those that survive often emerge transformed, sometimes advancing rapidly by implementing new adaptive strategies. This pattern appears repeatedly throughout prehistory, suggesting a cyclical rather than linear model of human development. Periods of growth and increasing complexity followed by collapse and rebuilding, driven by climate fluctuations beyond human control. The emerging scientific picture suggests a human past far more complex than any existing framework fully captures. Our ancestors faced and survived multiple catastrophic climate events, preserving crucial knowledge through dark ages of collapse and regeneration. Their resilience challenges our conception of prehistoric humans as primitive or unsophisticated. It suggests that cognitive complexity, innovative capacity, and social organization have deep roots in our species' history, emerging whenever environmental conditions allowed. As we integrate these scientific breakthroughs into our understanding of human prehistory, a new narrative begins to emerge, one that recognizes both the linear accumulation of knowledge and the catastrophic disruptions that have repeatedly tested human resilience. Chapter 10. Echoes from the drowned world. We've journeyed through archaeological anomalies, ancient myths, and cutting-edge scientific discoveries. Now we must confront the central question that has guided our investigation. Did advanced human societies exist before the end of the last ice age? The answer, like human history itself, is more complex and nuanced than a simple yes or no. The evidence we've examined suggests a third possibility, one that challenges both conventional chronologies and speculative alternatives. What we know with certainty is that anatomically modern humans with brains identical to our own have existed for at least 300,000 years. For most of that time, they lived in a world dramatically different from ours, a world of cycling, ice ages, and abrupt climate transitions. During this vast period, these humans with minds as capable as our own witnessed sea levels rise and fall by hundreds of feet. It experienced temperatures swinging by 10 degrees Celsius or more within lifetimes. They adapted to environments transforming before their eyes. The central revelation emerging from our investigation is this: human achievement before the end of the last ice age was neither as primitive as conventional archaeology has suggested, nor as technologically advanced as some alternative theories propose. The truth lies in between. What the evidence increasingly suggests is that ice-aged humans developed sophisticated specialized knowledge in specific domains, particularly astronomy, mathematics, and monumental construction. While lacking many technologies we associate with advanced civilization, they achieved this specialized complexity through multi-generational observation and knowledge transmission, creating intellectual traditions preserved through oral teaching, encoded in myth, and embedded in monumental structures designed to survive catastrophic events. This specialized knowledge wasn't uniformly distributed. It developed in specific regions with environmental conditions conducive to larger, more stable populations, particularly along no-submerged coastlines where marine and terrestrial resources could support greater population density. When catastrophic climate change struck at the end of the Younger Dryas, these coastal knowledge centers were disproportionately affected. Rising seas inundated their settlements, forcing survivors inland where they influenced subsequent cultural developments. This explains one of the great paradoxes of archaeology: why sophisticated knowledge in astronomy, mathematics, and monumental construction appears suddenly in early agricultural societies, seemingly without precedent or developmental stages. It wasn't developed suddenly, it was preserved knowledge, transmitted by survivors from coastal societies with longer intellectual traditions. The apparent sudden appearance results from the destruction of earlier developmental stages by rising seas. This model resolves another paradox: why the world's oldest myths consistently describe advanced knowledge coming from beings who survived a great flood. These weren't gods or aliens, but human survivors from more developed coastal societies destroyed by rising seas. When these survivors integrated with inland populations, their specialized knowledge would have appeared extraordinary. Their ability to predict celestial events, their mathematical understanding, their architectural techniques, all would have seemed almost supernatural. Over generations, as this knowledge was transmitted through oral tradition, these human teachers were gradually transformed into the gods and culture heroes of world mythology. Beings who brought civilization after a great flood destroyed the previous world. This explains why ancient texts worldwide describe civilization as a gift brought by specific teachers rather than a gradual invention. From Oannes in Mesopotamia to Viracocha in South America, from Osiris in Egypt to Quetzalcoatl in Mesoamerica, all are described as bringing knowledge after a flood. The timing is significant. These civilizing figures appear in world mythology immediately after the catastrophic climate events at the end of the Younger Dryas, precisely when rising seas would have forced coastal populations to migrate inland with their preserved knowledge. This model also explains the remarkable similarities in astronomical knowledge encoded in monuments across supposedly unconnected cultures. This wasn't independent invention, but knowledge transmitted from shared sources, survivors who carried their understanding inland as seas rose. It explains why early agricultural societies appear with seemingly advanced understanding of plant genetics and cultivation techniques. This knowledge wasn't developed overnight, but preserved from earlier experiments in plant management by coastal societies now underwater. The evidence for this model comes from multiple converging lines of inquiry. Underwater archaeology has revealed submerged landscapes with features suggesting human modification at depths corresponding to Ice Age coastlines when seas were hundreds of feet lower. Genetic studies have identified population bottlenecks and subsequent expansions precisely when catastrophic climate events occurred. Ancient DNA analysis shows complex population movements and mixtures immediately after the Younger Dryas, consistent with coastal refugees moving inland. Geological evidence confirms catastrophic sea level rise at exactly the time when flood myths say civilization was destroyed. Archaeological evidence shows the sudden appearance of sophisticated knowledge in early agricultural societies immediately following these events. Most compelling is the astronomical knowledge encoded in ancient monuments worldwide, structures separated by thousands of miles, and supposedly different cultural traditions incorporate identical understanding of celestial cycles, often using similar mathematical principles. This specialized knowledge, particularly understanding of precession, which requires multi-generational observation, appears too complex and too similar across supposedly unconnected cultures to have been independently invented. It suggests transmission from a shared source. What emerges from our investigation is a new narrative of human prehistory, one that recognizes both the gradual accumulation of knowledge and the catastrophic disruptions that have repeatedly tested human resilience. In this narrative, human achievement isn't a steady march from primitive to advanced, but a complex interplay between development, catastrophe, preservation, and rebuilding. Knowledge is gained, lost, preserved in fragments, and reconstructed by subsequent generations. This narrative has profound implications for how we understand ourselves. It suggests that our capacity for intellectual achievement isn't a recent development, but an inherent characteristic of our species, emerging whenever environmental conditions allow for its expression. It transforms our relationship with catastrophic climate change. Rather than seeing it as a novel threat, we recognize it as a recurring challenge that has repeatedly tested human resilience throughout our long existence. Most importantly, it humbles us. We are not the first to achieve heights of knowledge, nor are we immune to the forces that have repeatedly reshaped human destiny. We are participants in a much longer human story of achievement, catastrophe, and renewal. The world before the flood wasn't a technological utopia with advanced machinery or electronic devices, but neither was it primitive. It was a world where humans, with minds identical to our own, had accumulated thousands of years of specialized knowledge in specific domains. When catastrophic climate change destroyed these knowledge centers, survivors preserved what they could, carrying mathematical understanding, astronomical knowledge, architectural techniques, and agricultural expertise to new regions where they influenced subsequent development. This is the true story of life before the Great Flood. Not a lost technological paradise, but a drowned world of specialized human achievement. Not aliens or gods teaching primitive humans, but survivors transmitting preserved knowledge after catastrophic climate change. It is a story written in submerged landscapes, encoded in ancient monuments, preserved in world mythology, and confirmed by cutting-edge science. It is a story of human resilience in the face of catastrophic environmental change, a lesson with profound relevance. For our warming world, as we face our own climate crisis, we can draw inspiration from this longer human story. We are not the first to face such challenges, nor will we be the last. The question is what knowledge we will preserve for those who come after us. As our journey concludes, we return to the shoreline where we began. Waves rhythmically washing against ancient stones, a pulse that has continued uninterrupted since the last great cataclysm that reshaped our world. Standing here, we can now perceive echoes of the drowned world beneath the waves. Not a lost technological utopia, but communities of humans with minds as capable as our own, developing specialized knowledge over thousands of years of careful observation and record-keeping. When catastrophic climate change transformed their world, these ancient knowledge keepers did what humans have always done. They adapted, preserved what was most precious, and began again. Their legacy lives on in the astronomical knowledge encoded in ancient monuments worldwide. It survives in the mathematical principles embedded in structures from Egypt to Cambodia, from Mexico to Peru. It echoes in the world's oldest myths, which preserve cultural memories of catastrophic flooding and the preservation of essential knowledge through dark ages. This longer human story transforms our understanding of ourselves. We are not merely modern people with ancient ancestors. We are the inheritors of intellectual traditions with roots far deeper than conventional chronologies recognize, traditions tested by catastrophe and preserved through resilience. As we face our own climate crisis, this perspective offers both warning and hope. Warning that civilizational collapse due to environmental change is not merely theoretical but has potentially happened before. hope that our species has demonstrated remarkable adaptability. The true revelation is not that aliens or gods taught primitive humans, but something far more profound, that our capacity for intellectual achievement, creative problem-solving, and knowledge transmission through catastrophe is an inherent characteristic of our species. The story of life before the Great Flood is ultimately our story, a testament to human resilience in the face of environmental upheaval. As inheritors of this longer human journey, we carry forward not just our own innovations, but fragments of ancient wisdom preserved through millennia of catastrophe and renewal. Perhaps that is the greatest lesson from our investigation, that human knowledge is precious and vulnerable, requiring deliberate preservation through times of crisis. As we navigate our uncertain future, we would do well to consider what knowledge we will safeguard for those who come after us. If you've found this exploration of our deeper human story valuable, please consider subscribing to our channel for more investigations into history's greatest mysteries. Together, we'll continue peering beyond the horizons of conventional understanding, seeking wisdom in the echoes of our most ancient past.